other human beings are surrounded by data. So you know what? Till 2024, each and every person is creating approx 3 megabytes data per second. So just try to imagine how much huge amount of data we have. So basically data is increasing rapidly. That's why we have a boom in the jobs of data field. We have a jobs of data scientist, data analyst, data engineer, statisticians, and many other roles as well. But you know what is going in data science industry? Even more than 30 to 40% of the data scientists, they are lagging in their statistical skills. We all are talking about AI, machine learning, deep learning, natural language processing, and all these stuff. But you know what? Statistics is the core of AI. Statistics is a base of AI. So if you want to smoothen your path to get into data science industry, you have to work on your statistical skills. That's why this course is for you, in which you will learn each and everything from scratch, and you are able to relate all your statistical knowledge with your real life use cases. Statistics. So today we are going to discuss what exactly is statistics, and as we go straight forward into our course, we will discuss all the basic concepts of statistics as well as all the advanced concepts that will lie under statistics. So if you are watching this video on any platform, so it means you are creating some data. Similarly, suppose you are browsing or surfing on your phone or laptop, and if you are doing some transactions from your phone, so it means you are creating some data. So similar to you, there will be lakhs or there will be crores of persons that are doing same activity. It means they all are creating some data. So from this graph you can see their data is increasing in a exponential fashion. So this data is increasing in a exponential way. So what exactly statistics is? It is basically a science of collecting this entire data, and then I have to organize this data, and then I have to present, and then after it I have to analyze this data and getting some insights from data. So that's all about statistics. So if I have to summarize this statistics, so statistics is all about how you are going to represent your data in a informative way. So before approaching your any of the business scenario problem, you have to understand your data very well. So for this you have to professional in statistics, or I can say you have an awesome command over statistics. So statistics is all about representing your data in an informative way and deriving some insights from it, and then you can create a story with that data and represent to your stakeholder, and it basically provides a robust solution to complex business problems. So if I have to talk about main components of statistics, the very first one is my descriptive statistics. So descriptive statistics is all about that describes my data very well, or I can say that describes data in an informative way. So if I have to consider example, so how COVID-19 cases rise in USA or India. So that's a example of descriptive statistics. So by visualizing our data, we can say it somehow increases in a exponential fashion, where I have on y-axis I have number of cases, and here I have different dates. So let's talk about second main component of statistics, that is inferential statistics. So inferential statistics is all about when we try to understand trend of the population on the basis of sample. So that's all about my inferential statistics. So inferential statistics, if I have to consider a real life example, suppose if I have to estimate what exactly is the mean salary of all the data scientists in India. So what you can do, instead of collecting data of lakhs of data scientists in India, you can collect somewhere data of 1,000 data scientists of Delhi or Bangalore, and on the basis of mean of this 1,000 data scientists in India, you can estimate I will somewhere around 15 to 20 LPA that is my lakh per annum, that's somehow my mean salary of data scientist of India. So what exactly is your approach here? You are trying to infer the mean salary of lakhs of data scientists on the basis of this 1000, which is my sample. So on the basis of sample, you are trying to estimate, this is exactly my sample. So on the basis of sample, you are trying to estimate the mean salary of all the data scientists in India. So let's talk about what is distribution. That is our third main component. So distribution is all about how your data is distributed, in what fashion your data is distributed, whether your data is distributed in an exponential fashion, whether your data is distributed in normal fashion, or whether there is any skewness in data or not. So we will discuss all these stuff as we go straightforward into our course. And the last one component is basically hypothesis testing. So if I have to summarize this terminology, it's all about assumptions and some evidences. So it is just like a laboratory where all the assumptions and observations that we make from data are actually tested using foolproof method. So that's all about this session. Hope so you will love this session. So thank you. Have a nice day. Keep learning. So today we are going to discuss what is the use of statistics in data science. So in data science and in analytics domain, we have various job titles. We have business intelligence specialist, we have data engineer, machine learning engineer, data scientist, deep learner engineer, and many other job titles as well. So whenever a client or a stakeholder comes with a use case or a problem statement, so in such case, business intelligence specialist will talk to that client and understand what exactly is the use case. Then with the help of domain expertise, we will try to understand what this use cases require, what data this use case requires. So very first, we must have our business understanding related to our use case. Then the very first step is basically we all will have a data collection state. So either we can collect our data from some survey or some warehouses, or whether the data may be available from third-party APIs or some databases as well. Then we have to check whatever data I have collected from here, then I have to check whether this data is in right format or not. So this task is basically done by our data engineer. So what exactly task is? He will check here whether there is a missing value in data or not. He will do all the feature engineering in our data and all these different stuff. So he will basically pre-process our data and make it ready for the analysis purpose. Because in real life use case, whatever data we will get, that will be of raw type, that will be of raw data. So we always have to deal with that raw data and make it ready for the analysis and for the prediction purpose, so that we can derive some insights and we can do some predictions on that particular data. So very first we have to process that data. So in such case, data engineer will come into existence. So basically he will deal with what technique I have to apply so that how I can deal with missing values. So in that particular use, there is an extensive use of statistics, or whether if he has to standardize our feature or normalize our data. So in such scenario, there is an extensive use of statistics. So that's a place where statistics come into picture. Then data mining specialist and data analyst will derive some insights from data. So, or I can say some meaningful information from this huge data. So in this case, they will use some statistical analysis on data and try to get some insights from data. So once you derive insight from data, that data will be sent to your machine learner engineer, and that machine learning engineer has to build some model that will do some predictions. So how ML engineer will decide which machine learning algorithm is good? So it is basically selected on the basis of accuracy and cross validation and confusion metrics that we all have discussed in our later classes. So when machine learner engineer try to find which machine learning algorithm is good, so in such scenario our statistics is a backbone. Suppose you have a very complex use case and you are not getting good accuracy. Suppose your accuracy will somewhere around 30%. So in such case, ML researcher will come into existence and he will try to create his own algorithm, and on the basis of algorithm our model will get trained, and then our model will do some predictions, and then we try to get a better accuracy before that. So when we are trying to build a new algorithm, there is an extensive use of statistics, because machine learning is all about how we are going to train our model, how we are going to find some patterns in our data. So whenever we are trying to find some patterns in our data, there is an extensive use of statistics there. So that's all about this session. Hope so you are able to understand what exactly is the use of statistics in each and every role of data science. So that's all about this session. Thank you. Have a nice day. The course of statistics. So in this lecture, we are going to cover about what are random variables. So random variables, if I have to define it, so I can say, suppose you are performing some experiment. So the outcomes that you are getting in some real numbers or in some format. So random variables are basically a set of those real numbers. So if I have to represent random variables, so I can say it's a set of outcomes. So those outcomes are basically x1 to xn. So let's move ahead to the types of random variables. So random variables are basically of two types. First one is discrete and the second one is continuous. So the major difference between both is discrete random variables are those random variables, I can say, that consist only of whole number. If I have to consider an example, I can say a number of a bank account a person has, or population of a state in terms of millions or in terms of lakhs or in terms of crore. So these are examples of discrete random variables, because here data is in the form of discrete nature. So if I have to define continuous random variables, I can say these are those random variables that consist of decimal values, or I can say, or that consist any values within a range. So suppose if I have to consider a height of 100 persons, that of course lies within a range of somewhere between 4 feet to 6 feet. So these are basically my continuous random variables. So in this range I have 100 values. So these values are my continuous random variables. Or I can say age of a person, if I have to say in terms of suppose 11.2. So that basically means he is 11 years and somewhere between 2 months and some days. So this is in the term of continuous random variables. If I have to consider age in terms of only 11 years, then this is my discrete random variable. So let's move ahead to the next topic, that is what is population and sample. So if I have to define population, I can say population is my entire data. Suppose I have a data of 1 lakh persons. So I have a data of 1 lakh persons. So these 1 lakh persons data are my population. If I have to represent something like this, so suppose these are my 1 lakh persons. So these are my population. So sample is basically a subset of population. So suppose if I have to consider 10,000 persons randomly, I can say, so suppose these are my 10,000 persons. So this is my sample. So one of the very frequent question is why we are going to take sample. Because suppose if I have to do some analysis, or I can say if I have to do some operation, and I can say if I have to calculate the mean age of these 1 lakh persons, suppose I have to calculate the mean age of these 1 lakh persons, then practically it is impossible to collect these huge data. Because what if this count is somewhere between 10 crore or I can say 100 crore, so it is going impossible to collect this huge data. That's why we are going to consider the sample. we will just take sample of 10,000 persons randomly, and then we are just going to take mean of those samples. Similarly, decision of exit poll at the time of election, how any media is going to take decision that which party will win. So what they will do, they will take basically a sample. Suppose in India, suppose 80 crore persons opt for votes. So what they will do, they will just take a sample of around 10 lakh, because it is impossible to take data of 80 crore Indians. So what they will do, they will just take a data of somewhere around 1 lakh persons, and based on that 1 lakh persons, they are come up with some insights or I can say some decisions. So if I have to compute a mean of sample, then so I can say mean is nothing but so this is the sample mean of 10,000 persons. This is a sigma I1 equals to 10,000 xi. So this is what x1 plus x2 plus x3 till xn divided by 10,000. So if I have to compute population mean, what we will do, so here I have a summation from I equals to 1 to 10,000. So 10,000 is basically this. This is our sample. So suppose my population is around 1 lakh. So population mean is basically I equals to 1 to 1 lakh. So same formula it is. It's not fancy. So yeah, that's all about the session. I hope you love the session very much. Thank you.